Hello, this is a HaLRGB processing tutorial for Pixinsight. This was requested by Swordfish, who generously let me have access to some of his data, and he thought that a wider audience might benefit from these processing steps. Open the masters. These are auto-cropped in WBPP, the weighted batch preprocessing script in Pixinsight. This is just the crop mask. It's not relevant, so just close all these out. If you don't have auto crop and plate solution for your masters, find a way to crop them all to the same aspect ratio and then plate solve at some point. First thing I like to do is to set the identifiers, because I have custom icons that make this much easier instead of having to select them every time. Again, for this, we have hydrogen alpha, luminance, red, green, and blue masters. And I do apologize, I have the respiratory virus that's going around here in November 2024. It's a bit of a lingerer, so bear with me. It just is what it is. Alright, going to make a image container. Gonna add everything. And we're going to do a Graxpert background extraction. Normally, I would not recommend doing a blind background extraction like this, but I have previously worked with this data, and this data was taken in a Bortle 1 zone. There's basically no significant sky gradient in it. However, it does have a small flat field error that does need to be taken care of. And you can see that it's working in division mode, which means that it's trying to correct for flats. Okay, that's taken care of. We have concentric, bullseye pattern, which is very indicative of a flat field error. They are all roughly the same. So this looks like a good background extraction. The hydrogen alpha is going to be a little bit different from the other ones, but that's fine. It's still following a relatively concentric pattern, so that's okay. I'm going to disable all that, and we're going to disable that. Now we're just going to do a correct all with blur exterminator on the red, green, and blue masters only. You enable this by checking correct only in blur exterminator. I have a process icon set up for just this step because I use it all the time. My rationale for this is that the different filters are taken under slightly different circumstances, not so much the sky, but the angle of your scope can cause slight shifts in your collimation, mechanical flexure somewhere in your system. Maybe your focuser isn't completely bolted down and flexes a little bit. It might affect your tilt and things of that nature ever so slightly, which does show up especially in the corners of the images. So this corrects all those star shapes and makes them round. I do have hardware acceleration enabled because I do have an NVIDIA processor, or sorry, an NVIDIA GPU, and it makes it go a lot faster. If you can do that, I highly recommend it. Then on the luminance, we're going to do a fairly standard stock settings blur exterminator. Normally, when doing background extraction, going back a couple steps, I would recommend doing a starless dynamic background extraction, or if you have a sparse star field, you can even leave the stars in. The problem with this data is that it has an extremely dense star field and there is signal everywhere in this background, actual signal. This data set is about 100 hours in total, so it's quite a good data set. And there is signal error in this frame. So it can be difficult, not impossible, but difficult to do it manually. And for this particular data set, it just happens to be that GragSpert does a good job and it's appropriate and it looks good. Close that. So now we want to first set up our hydrogen alpha for the recombination with the RGB data. This is going to happen at the very end of this process, but it's best to get this started now, just to kind of get out of the way, because this red is going to get manipulated in other ways, and I prefer to just get it done ahead of time so I don't have to backtrack. So the first thing is to do a linear star exterminator on both, and the difference is that you do not want to have the unscreened stars option selected when you're working with linear data. If it's stretched, then you would use unscreened stars. So we're going to do those both. All right, going to go script, toolbox, continuum subtraction, select the red channel on top and select the hydrogen channel on the bottom. And then we're going to crank this up a bit until I get something that I think looks appropriate. That's just kind of a stylistic or aesthetic judgment more than anything. That's way too much. Kind of like that. We can mess with that more here in a bit. Let's just try back down here and see what that does. Nope. Somewhere around 0.2 or 0.3 it looks to be about right. All right, so then execute that. It's going to give us an output. This is not stretched. To go back, undo the star exterminator. And this one here, we're not going to be using that for anything, so it doesn't matter that we revert these changes, but the RGB will get combined, so we need the stars for now. We go to generalize hyperbolic stretch, select a dimmer area of the field, maybe something like this, send it to the symmetry point, reset the screen stretch with F12, bump the local intensity up to the maximum, that's 15, and start stretching. Helps if you turn the preview on. Just want to get until the background starts to come out, and then we're going to use this fine adjustment slider to adjust the symmetry point such that the contrast in the background area is maximized, just like that. And hit apply, reset the tool. Now our data is sitting way above the black point, which we don't want. So we're going to go to the linear mode, shift the black point over to where the data starts, hit apply, reset. We're back into generalized hyperbolic. I'm going to set this stretch factor to 1 just to start off with, and start messing with the symmetry point to sort of maximize contrast, but it's pretty much already maximized with center point at 0, which is okay. Start to bring this stuff out a little bit. Now maybe bring down the shadow, because we don't want, what's going to happen is when we add this back into the RGB data, anything that has any kind of brightness to it is going to come out red, varying intensities of red in the image. So we don't want the whole thing to be red. That will look kind of silly. Maybe add some local intensity here. There we go. Start bringing out these brighter regions. We don't really want everything in the background to be popping out at us. Set. That seems all right. Now we have a problem with this big bright patch here in the middle, but we're going to take care of that. Close this. Going to do a 100% noise exterminator. You generally only do this when you're working with color channels that are going to be combined with luminous data or RGB data that's going to have a luminous addition to it. It just makes your colors look smoother, because otherwise it's just going to come out looking like a mess. Okay, that's much smoother now. I think I will go ahead and set up a mask for this bright area. Because that needs to be brought under control. If we add this back to the final product, it's going to look ridiculous. It's going to completely overwhelm the color that we get from the RGB data. When creating a mask like this, if you're using it feathered, which it is by, or gradient, which it is by default, I recommend you extend it roughly one diameter of your object on either side. That's a good starting point. You can fine tune that later. We've got this. We're gonna throw this over our hydrogen data, and we're gonna hit Control K to disable the visualization of the mask. Going to go to HDR multi-scale transform. These defaults should be probably fine, but I'm going to take this to a Gaussian 11 scaling function. Basically, the larger the structures you want to preserve detail for, the higher the number you're going to use. And inversely, the smaller the scale of the structures that you want to preserve, you're going to drop this down. This number right here, 3, 4, 5, 6, 7, 8. You're going to drop these down. This is all fairly large scale stuff from the sort. We're not working with a galaxy or anything like that with fine structure in it. So this should be fine. It's better than it was, but I think it can be better. I can never remember which way you go when it's too bright, whether you go up or down. There we go. So if it's too bright, you reduce your number of layers. If it's too dark, you go up in layers. We could probably actually take this down to something like 3. Undo it, redo it. Okay, this is just to tone it down a bit, and then we can remove the mask. Then I'm actually going to change this to something that makes sense. HA core mask. There we go. I'm going to apply an invert function to this. Invert, HI, invert, there it is. And then go to Process, Pixel Math, Editor. We're going to select our core mask and multiply that by the HA. And what it's going to do is anywhere that it's white, it's going to leave the HA image alone. Anywhere it's black, it's going to turn it black. And of course, in the gradient areas in between, it is going to slowly fade it out. So that's probably going to work, but we'll see. Never know. Have to look at it, but that's probably fine. So this mask here, this HA data is now done. Going back to the RGB, so I'm going to hit my RGB combine, and it already has preset the identifiers RGB, which I already set. So all I have to do is hit apply global. Boom, and it's going to look green when we do an automatic stretch. That's completely normal. We're going to do a spectrophotometric color calibration with automatic background neutralization. This usually gets us close enough to where we can then rebalance the color a little bit manually. If you want to get real nitpicky about it, you can select an area of background. I usually don't find that's necessary. And this is just going to color calibrate the image. We're looking for at the end is a nice tight grouping of dots around the sloping line, which means that our stars more or less were fit to the expected model. And that's what we've got. We have a couple outliers up in here, but that's completely normal. The vast majority of the stars fit. So reset the screen stretch with F12, Control A to do a new auto screen stretch, and now we have a normal-ish looking image. It's not very saturated, but it looks appropriate. All right, now we're going to do a full blur exterminator on the RGB data before we stretch it. All right. And then we're going to do Bill Blanchin's HT linked RGB stretch. These are some of the tools that you can get from Bill Blanchin. These are free. Only the Exterminator suite from Russell Croman are ones that you actually have to pay for. So we're going to stretch that automatically. I don't usually worry too much about the stretch on the RGB data if we're doing a luminance addition to it later. Reset the screen stretch, and then do a non-linear star exterminator keeping the stars. Probably should have renamed this before I did this, but that's okay. And it is to RGB stars. This is jeez, RGB starless. Well, we have some green noise here in the background. That's easily fixed with SCNR. Okay, no more green. And actually, I think about it, I'm gonna wait on that first. We're gonna color balance it first. Let's go back to the stars. Saturation, preview, and ramp up the global. Come on, this thing's so fiddly to grab a hold of this thing. We're gonna ramp this up until the orange stars start to get saturated. The blue in this particular data set is a bit behind the rest, but that's okay. Like that. I have a process icon set up for blue saturation. It's pretty easy to set one of these up, and then you can just drag the instance onto your desktop and save it with your process icons. Turn on our preview, bring this up a bit. Apply. Probably going to need a second pass. Maybe not that much. Just want it to where the blue actually starts to kind of stand out a bit. If you ever want to zoom in a bit, you can just hold down Control, drag your mouse across the area that you want to look at, and then release, and that'll bring you in. The diffraction spikes, they're pretty saturated, but they're not breaking at this point, so that's okay. And this is the brightest one, that's why I went for it. Hit this little back arrow, look at the whole image. I'm okay with that. Hit apply. Close the tool, close the preview. Go over to our Starless, open up histogram transformation. Hit the check mark. For some super reason, this doesn't automatically associate with the active image like everything else, but that's Pixinsight for you. And our histograms are out of balance with each other. Now, this doesn't always have to be balanced, but most of the time at this stage, it probably should be. So I'm going to select the green channel. I'm going to grab this slider right here, and I'm going to start dragging it over. I actually want to zoom in just a bit so I can actually really see these histogram peaks. And I just try to line them up. I'm not even really looking at the image yet. That, and now we have an image that looks much more color balanced. And I'll just drag this down here for the moment just to save it and just to see what happens. So if you try to, let's say we want the saturation of this area to be improved. There's so much green and blue noise. You see how over here the color that it is sampling is just bouncing all over the place. It's everywhere. So if we increase our saturation now, it's just going to put all kinds of weird stuff into our image. Don't want that. But if we do this, get out here, do this color correction first, then we can drop an SCNR on it. And now if we go back into, we don't need this guy anymore. If we go back into our saturation, go back to this area, preview, in here. It's bouncing out a little bit, but it's spending much, much more time in the reds. There's not as much of this nonsense hanging out here in the green. Most of it's hanging out in the red. So it's much cleaner from a color perspective, and it's much easier to isolate, especially this dust here. So, I don't know why this thing likes to do that. Oh, because I'm highlight control. There we go. What's up? Now the nebulosity is really starting to get, or this bright part of nebulosity is really starting to get oversaturated quickly, much more quickly than the rest of the image. And we don't want that because it's going to be hard to fix later. So we're going to just bring this up to where it's kind of starts to fall apart, and then just back off a bit and apply it. And this is all over on this side over here. I'm going to shift the hue so that the area that we're interested in is more in the middle. So we want to set this. So this portion, oops, this dust is hanging out in the orangish area of the spectrum. This stuff here is more in the kind of magenta. So if we put a couple control points on either side of this hue, and then bring this point up, we can now selectively saturate the dust. And when working with the color data, pretty much want to oversaturate your color data. You don't want to break it, but you definitely want to put as much saturation as you reasonably can into it, because when you combine it with your luminance data, you're going to lose a fair amount of that saturation, and you can always kind of boost it after combination a little bit, but if there's no saturation to start with, then you're going to have a really hard time. Apply that. And by the way, this process here was how I made the blue saturation. It's just I use that much more often. This one here, it's dependent entirely upon the subject that you're doing for an image, so you can't really set one that's just going to work for every image because every image is different. Whereas blue in a lot of images, especially the stars, tends to be weaker for whatever reason. So I use that one a lot, and I just made a custom icon for that. All right, now we're going to hit our color data with a maximum noise exterminator. Again, you only do this when you're working with color data for an HaLRGB image. You really don't want to do that if you're working on an RGB only image because it's going to make it look fake. Jeez. All right, now it's time to recombine. So I've got a process icon for that. It's just going to create a new image with a particular ID, so then that way the recombination pixel math expression that I have saved here on the desktop can find it. And we're going to replace, just because I like to keep my history explorer all on a single image so I know what I did. Get rid of this one because that's just copy. Gonna rename this one for a different pixel math operation. Going to use one of Bill Blanchen's star reduction pixel math expressions. And then we can close that, minimize that. And for now, we are done with this. So let me change this back to RGB, because that's what it is. Okay, on to the luminance. For this one, the stretch does matter. Now, I like the Bill Blanchet HT unlinked stretch just to get the stars. I like how the stars look after this particular stretch. But you can definitely stretch with the stars in if you want. It's just I don't generally care for how they look. It doesn't look as natural to me. So we're gonna do star exterminator, keeping the stars. And then undo the stretch, do a linear star exterminator, but not keep the stars. Do an auto screen stretch. Going to open up generalized hyperbolic stretch. We're going to find a spot that's kind of on the borderline between the data that is well captured versus the stuff that's kind of questionable. So this stuff in the background is kind of there, but it's even with this amount of data, it's not quite to the point where we can reasonably display this in any detail. This foreground stuff is very well captured, and if you just kind of follow it down, it eventually hits this point where it just kind of fades into mush. So I'm going to click right there, send to symmetry point. I'm going to ramp that local intensity all the way back up to 15, reset the screen stretch. No, that's not what I do. Buzz off. Hit the preview and start stretching. Change this to log view because that's how I like it. I just want to get it until the background starts to become barely visible. I'm going to play with the symmetry point, again, trying to maximize the contrast in the background. That looks about right. Hit it, reset, and once again, our data is way above the black point now, so we're going to do another linear stretch. So apply, set, back to generalized hyperbolic. I'm going to set the local intensity to 10 just to start with, and the stretch factor to 1. One, and now we're going to play with the symmetry point a bit. Maximize the contrast. So that local intensity a little bit. Generally speaking, for the first stretch, I'll have the local intensity at 10. For the second one, it could be, or sorry, for the first stretch, it would be 15. That's pretty much always. For the second one, it can be 10, but from there on out, it really depends on the results you're getting. But setting the local intensity to 10 on the second stretch is a good place to start. Apply that. Set our stretch factor to 1 again. So with our symmetry point, again, we're just trying to get so that we still have a fairly dark background with a hint of the stuff in the back, and then good contrast on the stuff that's in the foreground. That's pretty good. But again, now this part here is starting to get out of control. As a general rule, you want your K value, that is your brightness, on a scale from 0 to 1. You want the K in your luminance to be at or below 7, 0.7 rather, at maximum. Anything above a 0.7 on your luminance, and you start running into a situation where the color data cannot colorize it, it gets washed out. But there are ways to fix that. Also, the reason why I like to look at it in a log view is generally when you're doing a stretch, you want to have your data basically slope from the top left down to the bottom right, making basically a slope. Yeah, basically the opposite of this one. It's not always going to turn exactly like that, but it's a good goal. Basically what that means is that you have more or less maximized the contrast in the image. So now this area here is too bright. So we can do the exact same thing as we did before, but we need to undo that invert, apply it, Control K to hide it, HDRMT. We already know that this setting worked on the HA, but this is brighter now. So we're going to drag this on here and see if it tones down that HA area. And it did. Now our K is right just below or at 0.7 at the brightest, which is what we want. Need to remove the mask because otherwise we're going to feel silly. We're doing stuff later. And need a light passive noise reduction. This one here is going to be 70%, not 100, and see what we get. It might be too much. No, there's still a little bit of noise in there, so that's okay. You don't want to, especially with your luminance data, you don't want to overdo it because then it's going to look plasticky and fake. Some people say to never use noise reduction on your luminance data. I disagree with that, but that's up to everybody's own individual judgment. All right, next, local histogram equalization. This is a way to enhance certain details in your image. You don't have to do it. Some images don't need it, some do. So you basically mess with the pixel scales, the kernel radius. This is basically the size in pixels that of the structures that are going to be enhanced. If you ramp this all the way up to the maximum, then it's going to enhance the large scale structure in the image. It's going to increase the contrast on the large scales. If you take this all the way down to the very bottom, it's going to enhance the very smallest scale structures. And this looks like a mess or a Van Gogh painting, whichever you prefer. So take this back up to 32, and this is about, excuse me, the level of structures we want to deal with. Let's take it up to 64. I usually do in powers of 2, so 16, 32, 64 seems to be sufficient most of the time. But 32 seems to be the proper kernel size to enhance all this detail here, this interesting stuff. But you pretty much never want to apply this at full strength. You leave it on full strength to kind of dial in the effect, and then bring it back until it's enhanced but not overwhelming or fake looking. So to me, that's almost too much, but I think that's about right. So I'm just gonna go with it for now because this image is already published. This particular version isn't gonna go anywhere. Apply it. Close, close. Okay. So now I need to recombine starless, stars, rescreen. Now we have our stars back in. This one's just copy. We don't need that. This one can go hang out up here. This one we're going to rename for the star reduction method. And we use the exact same method to reduce the stars in the luminance because we want them to match. So now we have our luminance, we have our RGB. We are now ready for luminance addition to RGB. I have that set up right here. Basically all you do is you have only the luminance checked, and whatever your luminance image identifier is, you want it in here. If you need to find it, you can just grab it from the drop-down box. Drag it onto the RGB and hope that you didn't overstretch your luminance image. In this case, we did not. So now this is HaLRGB. You don't have to do this, but it just helps keep track of everything. This is now irrelevant. Pop in here real quick and look around. Looks pretty reasonable. I do think the local histogram equalization was in fact a bit much. It looks almost like a watercolor painting, which isn't really the effect that I want to go for. But that's okay. I'm gonna do HaLRGB combination. Go back to the luminance, undo. In fact, it's easier if you just go to History Explorer. Local histogram. So go back before the local histogram equalization. And then we need our luminance stars back. And we go starless, stars, rescreen. Get rid of the star copy because we don't need it. This is the original. Minimize that. Rename this. Get rid of that one. Star reduction. Don't need that one anymore. Can minimize this. And we go back to doing luminance addition. Okay, it's successful, and it's much more, I'd say, natural looking now. It looked a little, again, watercolor paintish. That's a nitpicky thing, but I didn't particularly like the effect. So I'm going to do start summary again. Rip those stars out. Do changes to HaLRGB because I forgot. Changes to GB stars like so. We're here for the moment, and that doesn't look too bad. Might benefit from a bit more saturation, but that's pretty normal after an HaLRGB combination like this. Bring this up a bit. I don't want a practical joke like this, but somewhere just kinda on the edge before it starts to look ridiculous. Kind of like that. This is a little bit oversaturated, but we now have our HaLRGB combination done, so it's not as big of a deal. It's still okay. Okay, that's handled. I think I might do a curves adjustment just to give ourselves a little bit more pop. This is on the RGBK channel, so it's the combined. We're just going to do a subtle little S curve. Gives a little bit more definition, a little bit more, I guess you'd say 3D effect. Want to overly darken the background, but just a little bit more contrast without losing it. And I hope this comes through decently well with the YouTube algorithm compression, but you never know. Alright. That's starting to fall apart in that core region. So I think what I'll do is I'll drag this process icon here, close this preview, find our core mask, redo the invert, put it on here, hide that, drag this process back on there. And now we've enhanced sort of the contrast in here, but we haven't blown out the core region. Remove the mask. Don't need you anymore because that's not saved in the history explorer. All right, you can do the hydrogen addition to the HaLRGB with stars in or not. That's up to you. It's probably a lot easier to visualize what you're exactly getting by leaving the stars out at this point. All right, where'd our HA go? Here he is. There's one more step that needs to be done, which is colorizing it. For whatever reason, the script with Pixinsight, it will do an HA addition with RGB, or sorry, with grayscale data, but if you do that, then it seems to clip off all but the very brightest information. So all this wispy stuff here in the background, you won't get it if you do it as a grayscale image. So there you go. Script toolbox. Where was it? Oh no, this is under utilities. MB color mapper. I'm going to select the HA grayscale, update, set. The hue is going to be at 0 because we want red, but we're going to change the saturation to 1. Apply. Yeah, unsaved. Okay, fine. Update. There we go. Now apply. Okay, so now I'm going to call this HA colorized. Can minimize this, pop it up there. Script utilities, backwards again. Script toolbox, combine HA with RGB. I do believe that this script is included in the base version of the latest release of Pixinsight. RGB view, we want HaLRGB. For our H alpha view, we want H alpha colorized. The amount is probably too much at this point, but we can adjust that here in a minute. Yeah, that's way too much. So I'm going to tone this down to like 1.2. Hit enter, see what it does. I mean, maybe if you like that kind of thing, but I don't want the entire background to be red. That's about right. About right. I think though, see what that looks like. That's too much. 1.2. Do feel like the low end stuff is a little bit too bright. That's a taste thing. So I'm going to get out of this. I'm going to open up the HA Colorized, hit the Curves tool, preview, and where is this stuff? This stuff is living right about here on the curve. So just take it, drag it down, take all this other stuff, and where do you live? You live right over in here. So it's right next to it. Don't want that. Ugh, I wish they would make it to do this. Might be a little bit overboard, but we'll see what happens. As Bob Ross says, there are no mistakes, there are only happy accidents. Alright, let's try this again. Script, toolbox, combine HA with RGB. This is not a linear image, so get rid of that. HaLRGB is our colorized. H alpha is the H alpha colorized. We do not want a 2.0 combination. We want maybe a 1.2. 1.2. May even have to drop that lower because the brighter stuff actually got increased in brightness a bit. Let's try 1. Yeah, I like that. That's good. Apply that. Okay. Got hints of the stuff in the background without it just turning the whole thing red, which is what we want. So, stylus for rescreening. HaLRGB stars, bring those up. Doink. And rescreen, replacing the image. We don't need to keep any of the copies anymore because we already did our star reduction. That's the original. That's just copy. And we now have, does this need any more noise reduction? No, this does not. And we have a completed HaLRGB image. Hope this contains some useful information. If you have any questions, feel free to let me know.